Hi everyone, welcome to today's special technical webinar, in-depth discussion of Avalanche's high-performance architecture. We're featuring Actian's SVP of Engineering, Emma McGrattan, and Actian's Chief Product Officer, Raghu Chakrabarti. A couple of housekeeping items before we get started. If you experience any technical issues, let us know via the chat panel and we'll try to address them quickly. This webinar is being recorded, so you'll have a chance to watch it again or share it with your colleagues who couldn't make it. We'll send out a link in the next 24 hours. So with that, I'll hand over to Emma now. Emma?
Great. Thanks a million, Dahi. So what we're going to talk about today is really what enables us to deliver the performance characteristics that Actian Avalanche has become known for. And I think the highlight for me of today's presentation is going to be a demonstration provided by Raghu, who's also my boss, who's going to show us in real world use cases how we're differentiated from the competition. So some capabilities in terms of features we deliver, but much more interestingly, the performance demonstration that he has, where he'll show just how differentiated Actian Avalanche is compared to the competition. Hopefully you're here because you've heard of Actian Avalanche and you want to learn a little bit more about it. But if you haven't, let me just at a very high level tell you what Actian Avalanche is. Actian Avalanche is a hybrid cloud data warehouse. So you've probably heard of data warehouses, and a hybrid cloud data warehouse is one that can be deployed both on-premise and in the cloud, and you could go across multiple clouds if that's what your business required. We've designed Actian Avalanche for performance, and you'll be blown away by some of the numbers that we can deliver in terms of performance. And we say performance at scale because where we see that our differentiation really takes off is as data volumes increase. So the more data that we're crunching to solve your queries, the better the differentiation is with the competition. We're also great with the scale of users. What we find is that most organizations want to empower everybody who's making a decision for the business with the tools and the access to the data that they need to make the best decision possible. So supporting large numbers of concurrent users is something that we do incredibly well. And then if you were to measure query complexity on a scale, the more complex the query, again, the greater the differentiation with the competition. So performance for large volumes of data, large numbers of users, and large complex queries. And the platform is more than just a cloud data warehouse. It includes data integration capabilities. And Raghu is going to demonstrate for you how simple it is to use the Actian Connect capability to bring data in from other sources. So as you start to populate the warehouse, these pre-built integrations will make that task a lot simpler. With most cloud data warehouses, one expects to pay only for what you're using. So what that means is that if you have a peaky workload, and let's say at the end of quarter, which we're about to hit right now, you need to beef up the compute power that's being allocated to your cluster. We have the ability to beef that up to meet the specific business needs. And then when you get through your end of quarter processing and you close things out, you can then scale the resources back to what's required for the typical running of your business. The other thing that we do that I think is quite clever because it saves our engineering organization a ton of money is that we'll identify periods of inactivity in the service and shut it down. So for example, by default, if the service hasn't been used for an hour, it will automatically shut down by default. That obviously then, on a Friday evening when people are excited to get away from their desks and forget to shut things down, that takes care of that, and we're not paying for a service that we're not using over the weekend. So that one I think is quite useful too. And then the third part of this is that you're only paying for when the service is running. So if you have it's not typical, but if you had a 9-to-5 business operation and you only wanted to pay for the resources in that time frame, that's exactly what you'd be paying for. So only what you're using is what we'll be charging you for. And then the last point on here, this deployment flexibility. So this is all about the fact that we have designed this so that you can deploy where it makes sense for you, right? So when we started this year, there was a ton of excitement about going to the cloud. As we've gotten now to the midpoint of the year, a lot of the enthusiasm has gone out of that because a lot of CFOs are reallocating budgets for things like, improving the virtual presence so that employee base at home is as productive or more productive than they were in the office. So a lot of the budget that had previously been earmarked for migration projects like a data warehouse migration to the cloud, those budgets have evaporated. So what we're finding now is that there's a lot of interest in the fact that we can deliver on a hybrid solution. So if you want to deploy this on premises today, so reuse the hardware that you have, build up your infrastructure on premise today, and then move to the cloud as you're ready for that journey, our hybrid cloud data warehouse provides the ability to do that. We have a bunch of customers around the world. You've got some of the logos on the bottom of the screen here. And if you visit the Actian.com website, you can read more about what these accounts are doing with our technology, the business problems that it's solving for them, and how the performance that we can deliver really equates into increased business value for them. So that's that in a nutshell. So to me, the most exciting thing about Actian Avalanche is the performance that we can deliver because it's so differentiated. So what we've done here is we've taken an industry standard benchmark. It's called a TPCH. That's a decision support benchmark. It's intended to be industry neutral and to represent cross-industry set of decision support queries. The benchmark's made up of 22 queries, and we ran that benchmark against Avalanche, against Redshift, and against Snowflake. And what you'll see represented in the graph is the time it took to complete those 22 queries for each of those technologies. Now, time being money, right? For Avalanche, we're paying for only 349 seconds worth of activity. To run this on Snowflake, it takes almost 3,000 seconds, right? So about 9 times as much resources required to satisfy those queries on Snowflake. Redshift is, slower than Avalanche, coming in at 632 seconds. Now, we find that many POCs start with a single user, but in the real world, you're going to have a lot more than a single user on the system. So we reran the benchmark with 20 concurrent users. Now, a concurrent users means that they're actually hitting enter on the same query, on their queries at exactly the same instance in time. So these are being executed at the same time within the engine. And that's typically, it's a small percentage of your entire user base would be concurrent. So 20 concurrent users is about, I don't know, somewhere around 400 active users that are querying the system. So with 20 concurrent users, we see that for Avalanche, the time is 1900 seconds. For Redshift, it's over 5,000 seconds. So you see we start coming into our own now versus Redshift as more users come on the system. But for Snowflake now, their time is up around 21,000 seconds. So a big difference there as the user volumes increase. The other thing to note here is that we can deliver incredible performance on the same footprint as the competition is running. So if performance is really going to make a difference for you, if you're going to make more money based upon the fact that we're solving your queries a lot more quickly, then absolutely you want to run us at our fastest. But if maybe being twice as fast as Snowflake is good enough for a differentiation in your business, and you'd rather run on a scaled back set of resources, we provide the ability to pull that lever too. So you can have the performance lever, you have the price lever, and then you decide where upon the scale it makes sense for your business to deploy that. So the graphs, I think, are interesting, but much more interesting than a graph is to see this in action. So at this point, I'm going to ask Raghu to introduce himself and to provide a demonstration.
Hey guys, it's Raghu Chakrabarti. Thanks for joining us this morning. It's wonderful to be with you. So I wanted to start off, just a quick intro. So I'm the Chief Product Officer here at Actian, and let me share my screen. Hopefully it's coming through. Perfect. So I wanted to start off by showing you the differentiation in performance. So why would you consider anything different if you cannot really see the performance differentiation, right? So here I have kicked off a TPCH benchmark. This is a
Raghu, we're
live
seeing your
demo.
tax return.
Oh, sorry. So I've got the wrong screen. So let's see here. Stop sharing. And there it is. So hopefully you guys are seeing my proper screen now.
Yeah, we are.
Thank you. So here we have a benchmark that I've kicked off. Emma mentioned the TPC8 standard benchmark. So here we are running a TPC8 scale factor 100 benchmark on AWS. What we are comparing here is Avalanche that is stood up. You can see it up and running in this UI. And then we also have Redshift that is running in a live mode here. And we have provisioned Avalanche to be a really small cluster. 2 AUs is our standard, and that's the smallest possible cluster that we can have Avalanche running in. And we have provisioned a nice medium-sized AWS environment for our competitor X. And you all know who this is, and a Redshift medium-sized cluster as well. And as we kick off this demo, which is a TPC8 SF100 scale factor 100 benchmark with 10 concurrent users running at the same time, each one running 2 queries, you will see a total of 440 queries that will be run in this test. And Avalanche, as you can see, is well on its way. And the most important thing, guys, when it comes to performance is about cost for performance. So you're not only worried about, how fast can I run? Obviously, time is of the essence, but also a lot of times I've heard customers say, as I really throttle it up and make it really fast in the competitors that you see out here, the cost becomes a huge factor. So as you can see, Avalanche has already completed more than a third of its queries for 14 cents, whereas Redshift has completed a little less than that, but it's taken it more than twice the amount of the cost that it's taken. And competitor X is not even close, anywhere close to running this. So the important thing that you can see here is this, guys, right? Like, so on the right, as you can see the query execution time, you can see that green, which is Avalanche, has kicked off a lot more queries in the same amount of time compared to the other 2 competitors who haven't even started yet, right? Like with many of the queries. So would you rather wait for your queries to come back just so that you can stay with these guys, or go with the fastest available engine that's out there that can perform at the levels and give you the cost benefits that you really want to see, right? So I'll let this continue for a while. Let me go quickly show you what Avalanche is all about, right? And then we'll come back and see where we stand. So when you log into Avalanche, this is the UI you will see. Here is a list of warehouses. I've created a couple of warehouses here, but it's a simple step in terms of creating a warehouse. If you want to create a warehouse, just go click create warehouse and give it a name, and we deploy both in Azure as well as AWS as a managed service. Let's pick Azure. We support multiple regions in Azure and in AWS, so pick a region that's close to your thing. And here you have the ability to pick the sizes. Remember, like I showed you in the demo, we are running a 2 AU size. That's the smallest possible environment. And that is for the lower gigabyte loads. But if you want to go to petabyte scale, you create like larger data warehouses all the way up to 128 AUs. And by default, as you create these warehouses, it is locked out for access. So you have to give specific IPs or your company VPN IP the access to access this cluster so people can get to it. Emma talked about idle stop. We have that. So if there is no activity, you can have a setting here to stop the cluster when there is no activity, thereby it saves you cost. So once you create a warehouse, you get a detailed view around, what this warehouse is all about, right? So you have this running, and you have all of the IPs that have access to it listed right here. And the critical thing is that, we have this whole storage account authentication, where you can provide your authentication for your files that you might have stored in an ADLS location or in an S3 location. And you provide that authentication right here, and you can now create this whole notion called external tables, which I'll show you in a minute what that means. We also have third-party connectivity strings that are easily available for all of the common providers out here. So you would just come in and say, you know what, I want to connect to Power BI. You just come in here, cut and paste this string into Power BI, and voila, you can connect. All right. So what good is a good data warehouse if you can land data in it pretty easily? So we have integrated connectivity like Emma talked about, and we have various connectors, up to 200 connectors for very popular SaaS applications or popular databases that might be on-prem or in the cloud. And it's very easy to create a configuration. So here is a configuration for getting Salesforce into Avalanche, right? So it's as simple as using this configuration and providing your connectivity right here, and providing all your inputs, and you can run the configuration, and it will source data from your Salesforce account directly into Avalanche. Or you could load a CSV or delimited files from your ADLS location, like we mentioned, provide all of the inputs here, and you can run the configuration, and there it is. You can land data in a matter of seconds into this thing. So in this case, let's load Salesforce data from my Salesforce account into Avalanche, right? So you pick this configuration, you would run it, and then in the job section, you get access to the status as it's executing it. And as you can see, in a matter of a minute, you can actually land data from Salesforce directly into Avalanche. Okay, so that is a key important differentiation we have. And it's an important thing for you guys because it's very, what good is a data warehouse if you can't, again, land data easily into it? So let's go check back on this dashboard quickly. As you can see, Avalanche has completed the entire workload of 440 queries for a total cost of 43 cents, and in a time frame of 6.5 minutes. The competitors are still going at it. If you can see, the most popular data warehouse out there, competitor X, is still not even halfway there, and it's already costed more than 3 times the cost. And Redshift, as it completes its run, it's taken more time, and it's costing me almost 3x. Is this what you guys want to do? Right? Come on. You want to get the best performing, best cost-effective data warehouse out there, and look at each one of these queries, right? This is a standardized benchmark. We beat the competitor in each one of the queries, right? Like, so choose the best cost for performance, not just the time, but also the cost. And you will see that Avalanche makes a lot of difference for you. So now that we have seen this, right, like let's get into and start playing around with the data. So we have an integrated SQL editor. You can always bring your third-party tools like I showed you, but we have an integrated SQL editor right here where you can come and start playing with the data as soon as you land it, right? So I showed you that we can easily land data from a CSV file or Salesforce. Here is the table. A Salesforce account history is what we landed data in from the integrations run that we did, and also the CSV file is loaded into these tables. And we are pretty fast. Here is an aggregation query that would take minutes or multiple minutes to run in our competitors, and we do this in a fraction of a second, right? Going against millions of rows, against our sample airline data right here. We can do aggregations to show you which airport is the slowest or has the most delays. So please don't fly out of Bend, Oregon. Apparently that's pretty slow. So I also talked about the notion of external tables and accessing data without actually loading data into a data warehouse. So if you have a data lake and you have Parquet, CSV, JSON, whatever files you might have out there, you can easily reference those data without actually loading data in through our external table mechanism. Here I'm creating an external table pointing to a CSV file that's residing in my ABFS location, which I authenticated to when I created the cluster or when I created my warehouse. And I can create an external table pointing to the data that's in the CSV file. And here I'm creating another 7 million row Parquet file. I'm pointing to that and creating an external table to that, right? So It's as simple as that. We use Spark as the underlying mechanism to go access data from external files, and we represent or create a table for you so you can go work with it. And here I'm going to run a aggregation query joining a CSV table or CSV file right here and a Parquet file which has detailed data. And without even loading data in, guys, into Avalanche, right? We use Spark and the external table mechanism to go directly access the data that resides in these files and give you an aggregation or you can run an aggregation query in a matter of seconds. And we give you the flexibility. So if you're doing data preparation, if you're doing data discovery, these type of mechanisms, you just want to work directly against the files that are in your, data lake, and then look at the data, and then bring in the data. You can easily persist the data by creating a, create table as pointing to the external table, and bring in the data that's relevant to you and work with it. So we make it not only fast, but we make it highly performant and cost effective for you to work in a cloud environment, whether it's AWS or Azure, and make it really easy to use. So ease of use, performance, integrated connectivity is an important differentiation, and that's what we do. So we'll finish up because our competitor is still going at it. We'll finish up and I'll let Emma get back to her routine, and then we'll come back when this run is done. Thank you, Emma. Back to you.
Great. Thanks, Raghav. Appreciate that. That was great. One moment. Okay, so let's talk about the architecture that underlies Actian Avalanche. So as I mentioned already, it's a hybrid cloud data warehouse, meaning it's supported on AWS, Azure, and on-premise. We are working with Google to deliver on a Google Cloud Platform version later this year. And we're also working on a VPC, which is a virtual private cloud, which is essentially where you have your own cloud infrastructure carved out within, whether it's Azure or AWS, doesn't matter to us. But maybe you've got security controls that require that you're only running your own cloud, and maybe you've got better discounting ability with some of the cloud providers than we do, and we can actually deliver the Avalanche Cloud Service inside that VPC. Avalanche Connect, you saw Raghu there had a Salesforce example that he demonstrated. He had a NetSuite example lined up that he didn't demonstrate. He also referenced the fact that we can connect to things like Oracle applications or Oracle databases. Over 200 connectors come with Avalanche Connect, giving you the flexibility to connect to whatever you need. We have the, on Azure today, we have the separation of storage and compute. And what that allows you to do is to scale your compute resources without having to scale the storage resources at the same time. And we're currently working to deliver that same capability on AWS. We have on the compute side of things, we've done some things that are very clever. We call out some of them in this advanced cloud compute layer in the architecture diagram. But we're going to dive into each of these in subsequent slides. And that will help you understand how we can be so much faster than the competition and how we can deliver on that sub-second performance that we're known for. It looks like I messed up my slide on the robust access side of things. I spoiled some of the surprise that was coming here by having some logos on the screen already. But we are built for two different types of users. The business analysts who are going to be using tools like Power BI and Looker, Tableau, MicroStrategy, Click, the tool of their choosing, right? We optimize connectivity for some of these tools, but if you're using a tool that we haven't certified with, typically they'll have support through a standard ODBC or JDBC interface, and those drivers are provided as part of the platform. So the business analyst will definitely get what they need out of the platform, and it'll give them access to the data and the ability to do ad hoc querying in a way that they're not able to do with many other solutions, where they're limited to the data at a given point in time and not able to take an operational view of the business. We also have support for data ecosystems. These are the data engineers, the data scientists that live in tools like KNIME, that are using Spark SQL, that may be using Jupyter Notebooks against the technology. So we've built out support for those environments as well, all delivered as part of the platform. So let's talk about how we get to the performance characteristics that we do. And to do that, I think you need to think about, well, what goes into powering a data warehouse? And there's basically three elements. Well, there's fourth, there's network as well. But we've got disk, we've got RAM, and we've got CPU. And if we look at on the y-axis of our graph here, what you'll see is the time or the number of cycles required to process data from disk is up around the millions mark. For data that's in RAM, we're in a couple of hundred cycles. And if we're in CPU, we're in single digits pretty much, right? So if you think of that relatively, right, where you want to be is within the CPU and certainly not on disk. On the x-axis, what we're representing is the amount of data that can be processed per second, right? So depending upon whether you're running on spinning disks or SSDs, you're somewhere around a gig per second. In RAM, again, depending upon what you're paying for in generation of the chips you're running, it's about 20 to 50 gigs per second. And in the CPU, again, somewhere around 100 to 200 gigs per second. So again, it all points towards CPUs really where it's at and where you want to be if you want to deliver on performance. So what we've seen is that a lot of our competition have optimized for getting data off of disk and into RAM, right? So that's typically what they're doing. They're trying to avoid ever having to go to disk to read the data that's required to solve a query, and they want to have that data in RAM. So that's where they've spent their efforts in that whole optimization process. You want to make sure that the data is in RAM before it's needed, and you have got some very smart algorithms there for cache eviction and so on. What we said is, that made sense, 15, 20 years ago when some of our competitors were being architected. But today, given what we've shown you in the graph here, it makes sense for us to optimize for CPU. So that's what we've done with Actian Avalanche. And we're going to talk about that optimization in the coming slides. So first off is that we use a technology called vectorization. If you don't know what a vector is, you can think of it as an array of values. And many of our competitors use the opposite of vectorization, which is scalar processing. And if we were to do something very simple, so let's say we're calculating the total owed on a bill by combining both the goods plus the taxes that have to be paid on those goods. So we're adding two columns together, right? We've got the total spent, we've got the taxes that are being calculated and accumulated. Adding these two columns together, and we're going through our table doing this. Now, the sample here, we just have 5 rows, but imagine that you're doing this and you're the IRS, right? And you're calculating what everybody across the country owes you versus what they've paid you to figure out what's left to be collected, right? Imagine you're dealing at that kind of scale where you're dealing with hundreds of millions or billions of records that need to be processed. A scalar approach just doesn't make sense. And the bigger the analytics problem that you're solving, the bigger the drawback of using scalar processing is going to have. On the other hand, if you're using vectorized processing, right, we talked about a vector being an array. So now we're taking that set of values that represent X, which in our simple example here is the total for the goods that we're buying. And then we have our second vector, which is the taxes that we're collecting on those goods. And this is a second vector, Y. We have a single operation where we're going to join those two vectors of values together to produce the result set. Now, a vector is typically 1,000 values long, 1024 values, in fact. But it really depends upon the width of the data. So the wider the data, the shorter the vector. But typically, you can think of us as processing about 1,000 values at a time here. So by the time we've completed this operation for millions of values, the competition is still working their way through that scalar approach. So that's a big contributor to the performance differentiation that we provide. This capability is also known as SIMD, which stands for single instruction, multiple data. So think of our X vector and our Y vectors as the multiple datas, and that single instruction being that plus operation or that addition of those two vectors of values. So big contributor to the performance that we deliver, and something that we built the technology on top of this premise that vectorized processing makes a ton of sense for analytics queries. We're dealing with a lot of computations. The next thing that we've done, thinking back to the graph that I explained 2 slides ago, is we're using CPU cache as execution memory. Now, many of our competitors, and think of technologies like Oracle Exadata, right? They started life in the 80s. Think about some of the technologies like Redshift, which is based upon a Postgres front end, right? Started life in late 80s, early 90s. At the time those technologies were conceived, computers and servers in particular had about 8 megs of RAM on board. If you think about the modern CPU, they've got that much memory on board just in the local chip caches. So what we did with Actian Avalanche is to leverage that chip cache as execution memory for when we're running our queries. So we're not spending time figuring out how do we get data from disk to RAM efficiently. We're spending our time figuring out how can we take full advantage of everything that a modern CPU has to offer to deliver upon the superlative performance, and that's what we've done. So that's a second differentiation. The third is, and for those of you who understand how query optimization works, apologies for this very simplistic explanation of it, but essentially what we do is when you're going to solve a query, you lay out a set of steps that need to be followed to solve the query. You have data on the underlying data, so essentially metadata that tells you how that data is laid out, what that data consists of, and so on. And you build up a query execution plan that gets you to the end result for that query. What you'll then do is figure out the cost of each of the steps within that plan, and then figuring out, and that cost is things like how many clock cycles is it going to take in the CPU, how much RAM is it going to take, how long is it going to take to get the data from disk, is all of the data available in RAM already? All of these things are factored into generating a query execution plan. So we come up with the cost to execute that plan. We'll then rewrite that plan in as many different variants as it makes sense, and we'll parallelize that rewrite of the plan, and we'll figure out what's the lowest cost, right, for executing the best plan. And we will come up then with a parallel execution plan, and we will make every attempt to make full use of all of the resources that you have available to you. We talked earlier about concurrent users, right, and supporting lots of users issuing queries at the same time. And our goal is to make sure that every core that's allocated within your environment in Actian Avalanche is being kept busy all of the time. That's really their nirvana for us, is making sure that every core is being kept busy, because you're paying for those cores, right? You want to make sure that you're getting the most out of them. The next thing to note, and this really helps us on the disk side of things, is that Actian Avalanche is a column store. Many analytic solutions are column stores. Just because of the nature of the way you access the data, it makes sense to do it in a columnar approach. Because typically you're getting things like, get me the average balance, get me the maximum disk count, calculate the average on this column. So accessing the data in a columnar approach makes sense. Now, many solutions use a columnar storage format, but what we've done with Actian Avalanche is to go the next step, and that is that our data lives its entire life in that columnar format. So we talked earlier about the vectors, and actually what we store on disk is a compressed vector. So our data is stored as compressed vectors on disk. So we not only get the benefit of accessing the data as columns on disk, but also the benefit of not having to manifest those rows inside the engine, and not polluting our cache by carrying around all this extraneous information that we're not using to solve a query. So a pure column store, we call it a second generation column store, because in the first generation of column stores, they did what they said they did, which is they store data in columns. We actually have taken the next step, and we process the data as columns as well. So quite unique in that regard in how we've addressed that challenge. The other thing that, if you are familiar with column stores, you'll know that update processing is hard for them. And part of the challenge there is that you are storing your data as columns of data now. So as you're going to perform updates, you've got to update across all of the columns. In row stores, where the data is stored in contiguous blocks for, the data for that row is contiguous on disk, providing updates is a much more straightforward process. but for column stores, this is quite a challenge. We address that challenge with Actian Avalanche. So what you will see in Actian Avalanche is that you've got the ability to do inserts, updates, and deletes in real time. So if you had something like let's see, it's your ERP system that's feeding your warehouse, as your business is transacting, as those transactions are coming in through your ERP system, you can use a change data capture solution to feed that data in real time into the warehouse. And so not only can we provide support for those real-time updates, but we also do it in a way that doesn't impact the performance of running queries. So if you have queries that, if you have a bunch of users on the system, they won't even notice the fact that you've got this performance. That you've got, they won't notice an impact on performance of the fact that you've got these updates happening in the background. So again, another unique capability. Many of our competitors have tried to solve this problem by having read stores and write stores, and your updates happen in your write store, and your queries run against your read store, and then at a point in time you swap those around. Very convoluted, and what we wanted to do is make this simple. Everything we do about Avalanche is about the simplicity, and we wanted to provide for performance and simplicity in providing this feature. On the topic of simplicity, the next thing is that we automatically generate storage indexes on the data that we're writing to disk. So we'll keep track of the minimum and maximum value in every block that we write to disk. So then as we're solving queries, we just look at that index, right? And we can figure out which of the blocks that have data that's going to help me solve these queries, and much more importantly, which of the blocks that I'm not going to bother reading, right? So this really helps us narrow it down to just reading the blocks from disk that are going to be required to solve a query. So again, looking at efficiency and looking at simplicity, right? You don't need to create any indexes on your Actian Avalanche environment. Go with the default, use these storage indexes. If you do find that you require indexes for the particular set of queries that you have, we provide the ability to create those indexes. But by default, we suggest that you start without any indexes at all. Keep it really simple, because the goal here is to deliver high performance without you having to become an expert in how the system works and how best to tune it. The other thing to note about these storage indexes is if you have very wide tables and you have columns that aren't being queried, you can in fact turn off the indexes for those columns and save some memory if memory was an issue. And then the third item with respect to simplicity is this smart compression. So I know from my experience with Redshift that you can spend a lot of time figuring out what's the best algorithm to use for compressing your data so that you can get a balance of performance and also footprint on disk. With Actian Avalanche, you don't even need to know anything about the compression algorithms that we use. We'll figure out for each block of data that we're writing out to disk, what's the best compression algorithm. So for column stores, compression makes sense because it's going to reduce the data footprint on disk. So the smaller it is on disk, the faster it's going to be to read and to write it. So compression makes a ton of sense. And when you're dealing with columnar data, right, so you know that all of my data in my customer balance field is going to be a float. All of the data in the first name field is going to be character. You know a lot about the data that's going to be stored in a column store. So you're able to choose compression algorithms that will make sense for that type of data, and then you go to the next step, which is to choose the best algorithm for the actual data that comprises that block. So some really smart compression algorithms will figure out for you what makes sense for compression. You don't need to play with this. You don't need to worry about spending time tuning it. We'll figure all of that out for you. We have chosen compression algorithms looking at the performance of decompression into the CPU cache, because we're all about performance and simplicity. So while that is our goal, is that performance side of things, we do typically provide about a 5-to-1 compression ratio. So it's a very good compression ratio, given that minimizing our footprint on disk wasn't the end goal here. How's that benchmark looking, Raghu? Have you finished on your competitor X yet, or are they still running?
It did finish, so I can go back and share and show you how this result worked. So the run finally finished, and I wanted to. This is the final result. So hopefully you see the right screen there.
We're seeing the right screen this time, yes.
All right. So competitor X finally finished, and I mean, here's the bottom line, guys, right? Like, so Avalanche took, 6.5 minutes, and it costed you 43 cents to run the entire workload. This is, again, a 10 concurrency TPC-8 scale factor 100 scale workload. Redshift took 3 times the cost, and it took more than 30% of the time to complete that run. And competitor X is going to cost you more than 5 times the cost, and it's going to take you 3 times the time to run this thing. So cost for performance is important. Time taken to execute is a very important factor, but ultimately everything gets driven by cost. And we at Actian give you the best cost for performance data warehouse out there in the cloud, whether it's AWS or Azure. So please do go try it out at actian.com/avalanche. Back to you, Emma.
Great, thanks, Raghav. Okay, so hopefully Raghu's demonstration, gave you sufficient interest to go off and try this for yourself. One thing that we found is that while the benchmark and the demonstration are quite compelling, there's nothing like seeing how this can perform with your data and your queries. So we have set up a free trial that we'll talk about in a few minutes. So it's the 6 things that I just covered, right? That vectorized processing, that single instruction on multiple data. It's using the CPU cache for execution memory, right? Processing the data in the chip cache, not in RAM. It's the multi-core parallelism where we want to keep every core that you're paying for busy, right? And that's how we can deliver on the numbers that Raghu just shared with you. It's this pure column store, right? It's the fact that we're not just giving you the efficiency of columnar I/O. It's the data lives its entire life as a column. So we're not manifesting rows. We're not polluting the cache with values that make no sense for the query that you're running. And we have the ability to provide support for what we call zero penalty real-time updates, right? So it's that real-time updates that aren't going to impact the performance of the running queries. Hugely important if you want to have a real-time view into your business. The storage indexes greatly simplify the environment, right? You don't need to understand an indexing scheme for the data. Go with no indexes by default. Trust the storage indexes are going to handle it. And then if we need to add indexes after the fact, we can do that. And then the smart compression, we've got the smart algorithms. You don't need to worry about what's the best compression algorithm for your data. We'll handle that for you. So it's these 6 things taken together that contribute and produce the performance that Raghu just showed to you. We're designed for performance on commodity hardware, and that's how we're able to deliver this performance in the cloud, because cloud's nothing but commodity hardware just built at massive scale. So this is the secret sauce, and this is what enables us to be as fast as we are running on commodity system. The performance that you've seen on cloud is representative of what you'll see on premise. So if you have an old Linux box that you wanted to try, see what performance you could get out of it, certainly we can work with you on that. And the other thing to talk about is this separation of storage and compute. So when Raghu did a demonstration of the Actian platform, if you were paying attention, you would have seen that where he had the 8 AUs allocated, to the right of that there was a scale that enabled, if he had pressed on that button, we could see that he could have scaled that environment right the way up to 128 AUs. So we can scale the environment to meet the business demands at the time. And we're able to do that using this capability called separation of storage and compute. So on this slide, what you'll see is we've got our storage sitting in a data lake, right? So this is our Avalanche data is sitting there on Azure Data Lake Storage. And then we've got our compute resources. And for simplicity here, I have 4 compute nodes that are being used to satisfy my mid-quarter business needs. Now, the way this works, and we don't want to get too technical here, is that the data that's in the data lake is broken up into partitions. Think of them as slices, and the responsibility for queries involving those slices of data is allocated to our compute nodes. So the way it's done is in a round robin fashion. So compute node 1 gets the first slice, partition 1, compute node 2 gets the second, and it goes around until all slices are allocated. Now, let's say, it's coming up to quarter end processing. Our CFO and our CEO are hitting refresh on their reports every 4 seconds to see if those new deals are coming in. They want to see the latest data. They want to see the changes as they're happening within the business. So we decide that we're going to scale the compute resources to meet this increased demand. And what we're able to do now is we've gone, just for a very simple example, we're going from 4 nodes to 8 nodes. And now that responsibility for the partitions is allocated over twice as many nodes, right? So if the workload remained the same, you would expect that your query response times is going to drop in half. More likely, the reason that you're increasing the capacity here is because you've got more users coming into the system because we're all working together to close out at the quarter. So there's more jobs being run. There's more interest in what's going on. So we scale up the resources. So we're able to do this on the interface. It's as simple as sliding along a scale, increase the resources, and then decrease them back to what it was at the what was required for the mid-quarter needs. So really simple to grow the horsepower to meet the specific needs of the business and to shrink them back again when you're done. As I mentioned earlier, this is available today on Azure, and we're currently working on a version for AWS. So in summary, if we talk about, well, what is Actian Avalanche's hybrid cloud data warehouse? So it's a hybrid in that it can be deployed on-premise or across clouds, right? Amazon Web Services, Microsoft Azure, VPCs coming in Q3, right, which starts next week. And then the on-premises. If you want to deploy on-premises, you can deploy on Windows, on Linux, on Hadoop. You choose. You can use VMware, you can use Docker. We'll work with you on what makes sense for your business. So it's an MPP, columnar data warehouse, right? So MPP gives us the scale that we need to meet the most challenging workloads. We talked about scale of the volume of data, the scale of the number of users, and the scale of the query complexity. All of that is handled by our MPP, columnar data warehouse. We're very much focused on open standards, and it's something that I guess I didn't call out already. And we actually chair the language body for the SQL language. So really focused on, as we implement features within the data warehouse, making sure to do it in a way that's standards compliant. And what that means is that, if somebody's migrating from another technology to ours, if they have adhered to standards, that's a very easy migration task. If they're coming from something that likes to snub its nose at standards and there's work involved in doing the migration, you can know that you're moving to a standards-based solution. So that migration task happens once, and we actually have some tooling that will help with that migration to Actian Avalanche. And we also support standard interfaces like ODBC and JDBC and the types of interfaces that you'd expect. We're really focused on performance, and hopefully the demonstration illustrated that, talking about the features and the thought that went into delivering on that performance may have convinced you. But as I said earlier, the most compelling thing is to see this running against your data with your queries and meeting your business demands. And I believe that you'd be very surprised by it. In fact, the typical first reaction we get is, but you must have known the results. It really is that fast that people think that we had pre-calculated the results for the queries they're running. We can deploy it anywhere, public cloud, on-prem, VPC. It's a fully managed service, so Actian Avalanche delivered as a fully managed service. We can provide a managed service on-premise if that's what you require as well. So we have a great services organization that would be happy to work with you on that. We talked about the separated storage and compute, and you saw an example of how we can provide that direct connectivity to SaaS applications. So Raghav had previously built an integration that enabled him to take Salesforce information, pull it into a table that was created within the warehouse, and it was very simple to run that. So the interface that Raghav showed you, where we have those integrations, is pre-populated with some templates. So the most commonly trodden integration paths, that we've encountered, we've built out templates for, so you just plug in your values, and it will enable that data integration. And then the cloud economics, paying only for what you use, right? So you saw in the interface the fact that you can specify the period of inactivity after which the service shuts down. You saw the ability to well, you didn't see it, but you can trust me on this. You can scale the environment to meet the needs of the business, and you can shut the service down when it's not being used. So you can decide you want to stop it, or you can trust that we'll identify periods of inactivity and shut it down for you. So that ability to take advantage of cloud economics is something that I believe will resonate right now, as people are very sensitive to what they're spending, right? So the ability to not just scale to what you need, but if your organization was really hurting and you want to say, you know what, let's scale back on the resources allocated to the warehouse. We understand it's going to impact the performance. There's nobody going to deliver the performance on the resources that Actian Avalanche can. So if you're very cost sensitive right now and you want to get the most out of the money that you are spending, it's definitely something that you should consider. And then the last thing on here is that we've built up a set of tools that will automate the migration from legacy data warehouses. So if you're using something today that's reaching its end of life, whether naturally or unnaturally, right? So what we've seen is that some people that invested in data warehouse appliances a few years ago had not anticipated data volumes growing at the rate they did. So those data warehouse appliances may have filled up much more quickly than was anticipated. And we have the ability to take some of that data, offload it onto Actian Avalanche, and then free up some space on the appliance for other workloads. So if it's a natural end of life and you're planning a migration project, our tools greatly automate that process. There may be some manual effort involved, but we typically will aim for above 80% automated migration. That's the target. So with that, we'll open it up to any questions that may have been asked while we were going through the thing. So Raghav, if you don't mind, while I'm getting these questions ready, do you want to very quickly show that sliding scale that we can use for increasing the size of the warehouse?
Absolutely, let's do
Awesome.
that. As we wait for questions, please do. I think it's going to get opened up for questions. So hopefully you can see this. So after you create a data warehouse instance, you have the scale button. By default created an 8 AU cluster. You can scale it up and down in this implementation. Let's say during some parts of the day, you want to go up to 16 or 32, and we can help you with these configurations in terms of what it can do. 8AU can easily handle up to 10 terabytes, and as you go into the petabyte scale, you would scale up and down, but also for concurrency, right? Like, so it's not just the data volume and the data size, but if there are 1,000 users that access the same amount of data during the day and then it goes down during the night, you want to scale it up and down. So we have that capability. You just click save and it automatically does the scale up, and then you can always come back down, and we have a scheduling feature pretty soon as well for this.
Great stuff. Thanks, Raghav. All right, so
For the audience, you can use the Q&A tab at the bottom to enter your questions.
okay, so first question we have here is, what tools are supported with Actian Avalanche? So, earlier on when we laid out that architecture slide and showed, some logos like Tableau and Looker and so on, we will support all of the standard tools that you will typically be using in your organization. The end goal is, if you're using tools like Tableau, you really should be, the migration from another data warehouse to ours really should be as simple as going into that connections tab that Raghu showed, copying the connect string for Avalanche connecting from Tableau and pasting that into Tableau and just repointing that workload against Actian Avalanche. It really should be as simple as that. So we have a number of certifications with the popular tools, and there's other tools in here like Beaver and Squirrel and so on, but it really should just be as simple as coming in here, clicking on the to the right of where it has the connection string information, copying that into your clipboard, and then it will, Vanna White over here is doing an amazing job, pasting it in then to your Tableau tool, and it should all just work. So yeah, that's that. Next question is the query tool that you used part of the platform, or is that an add-on? So the query tool that Raghu used, our query editor, is in fact part of Actian Avalanche. So as you go into your warehouses tab, and just as Raghu did just there, it's right there and ready for you to start. Yeah, the query editor to start typing in your queries. As Raghu mentioned, we find that when people get started with a new data warehouse, they lack imagination in what it is that they want to do with it. So we pre-populated the database with a year's worth of flight on-time information. So it's delays due to weather or machine equipment failures and so on. So there's, I believe it's about 7 million rows, and Raghu's going to find out for us now how many million rows there are. Yeah, there we go, 7.2 million rows of data pre-populated, and then we came up with a set of queries. So one of the ones that Raghu showed earlier was the top 50 airports with delays, top 50 flights with biggest average delays. So just giving you some sense for the the types of things that you can do with it. The other thing that I love is that there's a pretty print button there, Raghu, to the right of where it says top 50 flights with biggest average delays. That one, yeah, that too long from there. Next one, that's it. No, back one. If we press on this, see how it pretty printed the query. So to me, this is much more readable than what Raghu had. And now you can save this query. And next time you come in here to run this query, you'll actually see this pretty printed version of it. So it's a nice little feature. And yeah, that was a good question. It's provided as part of the platform. Okay, so the next question is, how much data volume can one single cluster handle? Say single table with billions of rows. So yeah, a single cluster can well handle billions and billions of rows. We really would need to understand more about how many tables, how many rows in each of the tables, what the query profiles look like, and before suggesting the actual size of a cluster. But as Raghu demonstrated earlier, we can support up to some very large clusters, and will easily handle billions of rows. We need to understand a little bit more to help size that specific environment. But we would be very happy, Suresh, to engage in a conversation with you about that. Okay, it looks like those were our only questions. All right, so thank you all for I'm sorry, there is another question. What kind of DBA tuning and optimization is required to achieve fast performance? So the ideal answer is 0, right? So hopefully with a combination of the storage, well, the performance characteristics that we deliver, just out of the box, the storage indexes that we provide by default, the smart compression that we use, you shouldn't have to do a whole lot in order to tune the environment. We will, because every workload is unique, we will work with you to take a look at what's happening within the system when we're running your queries, seeing if there are any optimizations that we can make to improve your performance. But typically, you should not require any DBA knowledge to get the most out of this system. It's a fully managed service, and really what the ideal is that you just load your data, and we'll provide some guidance on the different load paths. I mean, Raghu showed you a couple with the external tables. He showed you the connectors that we have in our integrations tab. Yeah, and you may be using tools like MicroStrategy or Talent or whatever to load data. I'm not MicroStrategy, but Informatica, Data Stage or Talent to load your data. We'll work with you to figure that out. Load your data, point your workloads at it, and it should really be as simple as that. Okay, so if there are additional questions that you want to submit, Rick, if you let me share again. Great, thank you. we have set up a special email address and a special promotion. So the first is that we will cut your Snowflake bill in half. So if you're currently a Snowflake user and you want to try Actian Avalanche, we guarantee that we can cut your Snowflake bill in half. And what Raghav showed you was that we can do much better than that, right? We can increase your performance dramatically as well as cutting your bill by more than half. But our legal team got involved here, and the promotion is that we'll cut your Snowflake bill in half. We would love for you to engage with us and to understand exactly how we can do that, and to give us an opportunity to show you your data, your queries running in Actian Avalanche. So we have set up a web microsite, actian.com/avalanche. You can learn everything you need to know about Avalanche. We also have set up an email address, which is our Actian Solutions Advisors. So if you contact asa@actian.com, so that one question we had about handling billions of rows in a single table, we can do that on a very small, a 2 AU cluster could in fact do that, depending upon how wide the tables are. But yeah, get in touch and talk to our solutions folks to figure out exactly what is required for your particular workload. And for those of you that are not running Snowflake today and who want to go straight to Avalanche, bypassing that step, we have set up a free trial of Avalanche for you. So we'll credit the first $500 worth of your Avalanche usage. It's good for 30 days. As you saw from Raghu's example, you can do a lot with $500. I mean, he was satisfying some very complex queries with pennies, right? So again, if you want to visit actian.com/avalanche, you can sign up today for a free trial, take advantage of that $500 credit. And again, contact us with any questions you might have, or if you wanted some help in getting started with that trial, asa@actian.com. So thanks for your time and for your interest and for the great questions that you provided today. And Raghu, great demo. Thanks for that.
Thank you, everyone. Have a good day.